In our last video, we saw how to make custom footprints and assign them to the symbols within the schematic editor. Today, we are taking it a step further. We'll transform our schematic into a fully functional printed circuit board that is ready for manufacturing. A part of this video is sponsored by JLC PCB. You can order PCBs as little as $2. We'll discuss the order process and shipping methods more in detail when we place order for our custom PCB board. If you have been following this series for quite some time, you might have noticed some changes in the circuit. Let's start by walking through some of the modifications I have made behind the scenes. For the input, I have included a USB-C circuit, offering a more convenient way to charge the battery compared to a regular header pin. Additionally, I have added a key switch and a LED to trigger the IC and serve as a flashlight respectively. Lastly, I have tweaked the output pins for easier placement on the PCB layout. These modifications are necessary, so I even built a version with our previous circuit, but the PCB looks too simple and impractical for many applications that I had in mind. The TP4056 is one of the most popular charging modules that's available in the market, so I thought it would be fantastic to create a version 2 of the famous TP4056 charging module. It's not something new, many have done it. However, I made sure this works as a drop-in replacement for the TP4056 with the exact size and dimension while retaining all the features of IP5306. If you prefer not to add this circuit manually, I'll provide a link in the description where you can download the schematic file. Alternatively, feel free to build the PCB with an existing circuit without any modification. First, let's start with the common mistakes beginners make when using EasyEDA. Creating a new PCB layout file directly from the file menu. Although it works, it doesn't automatically import all the components and the connection to the PCB editor, making the PCB design messy and challenging to work with. That's why we build the schematic first and then transfer the connection to our PCB layout. To do this in the EasyEDA, navigate the schematic editor and select Convert Schematic to PCB. This action will create a new PCB layout file in a tab and prompt you to enter your new PCB's dimension. Most options in this pop-up are self-explanatory. Set the units to mm, number of copper layers to 2, board outline to rectangular, and then start X and start Y to 0, which positions the PCB outline at the center of the document. Finally, enter your desired width and height for your PCB dimension. Since we are trying to recreate version 2 of the TP4056 module, we'll use its dimension, that is 27 mm in width and 17 mm in height. Once the values are entered, just hit apply. You'll see an outline for your PCB with your specified dimension and all the components and connection from your schematic editor. Anyway, let's start with the placement of the components onto the PCB. First, always start with the bigger component or the main component and then work yourself down to the smaller ones. To move the component, click and drag it to the desired location on your PCB. In any case, if you want to change the orientation of the component, just use the shortcut R. I'll start with positioning the USB-C on the left side of the PCB for easier access. If you're finding the placement of the component a little difficult, it could be the grid's close interval snapping. You can adjust this value on the object pane in the left. Let's set this value to 0.5 mm. Now you'll notice a difference in how the components snap to the PCB, allowing for more precise placement. Alternatively, you can just select the component and directly adjust its X and Y location in the object pane. For instance, I'm entering specific value here to center the USB-C symmetrically on the PCB. Next, let's bring in the IP5306 IC. The Silklayer might obstruct our view at this point. You can just turn it off now and switch it back on later. However, since we need to fit as many components as possible within this space, I'm going to select the Silklayer text and delete it. Now let's bring in the larger components like the inductors and the LEDs. If you're unsure about their placement, you can always refer back to the schematic that we did for reference. Next, let's position the input and output jumpers as precisely as possible to mirror the TP4056 IC. It seems we run into a bit of a snag here. All the components won't fit within this PCB. We might need to slightly increase the PCB size. To do this, let's delete the existing PCB outline and create a new one. Go to Tools, click on Set Board Outline and increase both the width and the height by 1 mm. To 28 mm and 18 mm, then hit apply. Now we can move around the components and adjust them until everything is packed tightly. While doing this, just remember one major point. Input pins, USB-C and output pins need to be in specific spots with certain dimension because we are replicating the TP4056 module. So use the measure tool as often as possible to double check the distances. And once you're happy with the location, lock the component in place using the lock option in the object pane. Once the larger components are placed, make sure you refer back to the circuit often and try to place the components close to each other to avoid making longer tracks when you start the routing process. It might take a few tries to plan and place the components effectively around your PCB. So once you're satisfied with the layout, we can move on to the routing process. You might have noticed some connection floating across the PCB. These are called rat lines. They represent the connection made in your schematic, but not yet made the connections between the components on your PCB. The process of creating this actual connection on your PCB is called routing. It's quite simple to do in EasyEDA. All you need are these two tools, the track tool and the wire tool. To keep the routing process simple, you can use your schematic diagram as a reference and start routing from one side of the PCB to the other. Now to make the connection, start by selecting your track tool and clicking on a component which you want to start the connection. Here, let me start with the USB-C and the power inputs. Click on a pad where you want to start and another where you want to end the connection. But remember, drawing tracks within your PCB isn't always straightforward, especially when you're dealing with complex or high-speed circuits. There are many guidelines you need to follow to make the routing very effective. So I'll drop a link in the description which will dive deeper into the routing process in more detail, and also an article that will provide some basic outline of the PCB design guidelines. The first track was straightforward to lay out, but what happens when there is no way to connect the track on the same layer? In such cases, we need to use the bottom layer of the PCB to create a jumper connection. This is where the wire tool comes in handy, which helps us in creating a small hole to connect the top layer to the bottom and vice versa. Here's a simple example of how to use wire to make a jumper connection. With the basic guidelines in mind, start routing the rest of your connection. Please take some time and ensure you route everything accurately with proper spacing and thickness, as discussed in the design guidelines. You might notice some extra space on the length since we increased it by 1 mm. You can adjust this back by slowly moving the outline points slightly inward. This should bring us back on track with a size similar to TP4056 but 1 mm larger in width. But that shouldn't be an issue as long as we maintain the correct distance for pinouts like the TP4056 module. You might have noticed that I left out all the ground tracks because we are going to do a ground pour. This will connect all the ground connections together in a larger copper area. While you can complete the circuit just with tracks, a ground pour offers many advantages. It's easier to etch during PCB manufacturing, can act as a heat sink, provides overall circuit stability, and reduces EMI. To create a ground pour, select the copper pour tool and select the copper pour net name to ground. To do the pour, start drawing a polygon around the PCB by clicking at all the 4 corners. Once you complete the polygon, just do a right click and you will see how some of your ground rat nets connections disappear. So let's repeat this process for the bottom layer as well. If you notice any missing connection, like this ground not passing through the small space, you can fix it by adding a wire to both top and the bottom layer of the copper pour. This will make the connection between the top ground plane and the bottom ground plane. If you look closely at TP4056 PCB, you will see several wires on the bottom. These are called stitching wires and they are essential in many circuits for transferring heat from component to the PCB for thermal stability. So let's return to our PCB editor and quickly add this pattern to our circuit using the wire tool. With this, we complete our electrical connection. I usually add names on the Silklayer for easier assembly, but since our PCB is compact with little space on the top, let's add text on the bottom layer along with a logo. To do this, select the bottom layer on your PCB and use the text tool, and adjust its layer, content, font and the size in your object pane. For my need, this should be good. Let me finish this PCB off by adding a logo as well. To add a logo to your PCB, use the image tool in the PCB tools panel. In the pop-up, select your preferred logo. In this case, I'm using the pcbcupid's logo. Adjust these image settings until your logo is a perfect black and white image. Finally, set the dimension for your logo so it fits within the PCB design. Once you're satisfied with all the settings, place the components where you want it and click your mouse left button. If there is a lot more empty space, you can add more information as well. So let's quickly add the pcbcupid's website. This wraps up our PCB design using EasyEDA. If you like to see a quick 2D image of your PCB without this layer clutter, simply click on the 2D icon in the toolbar. And similarly, if you like to view your PCB in 3D format, click on the 3D icon. This will display a stunning 3D model complete with all the components used on your PCB. Currently, let's hold on manufacturing the PCB, because in our next video, we'll discuss more in detail about what is DRC and why it's necessary to perform DRC before doing Gerber generation. And also we'll learn how to create custom panels in EasyEDA for cost-effective and error-free production. That brings us to the end of this video. If you enjoyed this content and want to make more, don't forget to hit the like and the subscribe button. If you have any questions, please drop them in PCBcupid Q&A section. Until our next video, keep learning and keep creating.